Hello, are you excited to do some organic stuff? Time is 1:40, huh? We are going to start preparing for our organic sacks. Most of you are going to get organic sack next term, but we will start preparing for those this term. Then we are going to be super ready, huh? Super ready. I'm so excited. I hope that you are going to be excited as well. I mean, it's not that bad. Organic is not that bad. Unit 4 overall, it's not going to be bad or not going to be difficult like Unit 3. It's going to be okay. All right. All right. Let's start with this sack. Now, as you could see, we are going to start with a sort of a when it comes to difficult level, moderate difficult level. Okay, I might make mistakes because it's 140 is the time. All right, let's look at the question one. Propene is converted to propan-2-ol in a two-stage process. Now, when there's a question like that, it is really important that you draw it out, because at the beginning it's better to draw it out, then you are going to make less mistakes. So this is propene. Okay, all right, that's propene. Then do this is propene, isn't it? Okay. Oh, make sure there are no 5 bonds, right? What is the name of the test which can be used to confirm the propane is alkene? Now, even though we did not get a chance to talk about this test in class detail, but that's something that I will be doing next week. But you have, having said that, you might have learned that in year 11. Okay, what will happen? Look, think about this. Let's say we are going to add. Do you remember the addition of what halogens to alkenes? So what will happen if you add bromine? Bromine has got a unique color, which is brown. I think it's brown. Yeah, reddish brown color. The brown color, reddish brown. What I think it's brown, reddish brown. So look what happens when you add a bromine into a alkene. So there will be addition reaction. So because alkenes undergo only addition reaction, look look what happens to the structure of the bromine. I mean, look what happens to the structure of the bromine. See that? Well, carbon-carbon double bonds get broken. One of them, the addition reaction. So you see, the before it was Br2, now it's not anymore. You see that the structure of the Br2 change. Okay, Br. Okay, let me just. Sorry, what is going on here? Let me get that. Okay, what I'm trying to say is this. If you look at the structure of the Br2, this is Br2, and which is brown in color. This is brown, right? So when it gets added into alkene, the structure of the bromine changes. It gets broken down. So the color changes. So that is the test. So you have to say, what is the test? This is called the bromine test. The color of the bromine changes from brown to colorless. Color of the bromine changes from brown to colorless. When bromine is added into alkene. That's not that difficult, is it? Yeah. We will go through this test in detail later. Okay. All right. The next question. So we covered that. This is bromine test. We are at bromine test. Not bromide test though. It's bromine test. Then what do you have to say when you add a color? When you add bromine into an alkene, the color of the bromine changes from brown to colorless. Okay. What is the molecular formula of the compound B? All right. Compound B, propene, compound B. Maybe, sorry, we need to have read this before. I forgot to do that. So propene becoming compound B and propan-2-ol. Propan-2-ol alcohol, isn't it? Propan-2-ol. So when you are starting with the alkene, if you want to convert into an alcohol, all right. So, I mean, this is a common reaction pathway. You start with the alkene, you do addition reaction. And then you can you do a substitution reaction to convert into alcohol. I mean, this can be done in one-step process. Propene can directly convert it into propan-2-ol if you want. Okay, But this is a three-step process. Look, so in this case, even though we could do this reaction in a one-step process, for this question we are choosing to go through a longer step, like three-step. We are choosing to go through more steps. This is based on the question. Is that correct? All right. Now, okay, let me show it to you how to do this pathway within what? Within two steps. Two step. It's very easy. You are starting with propene. Okay, I'm not answering the question. I'm just giving you some extra information for you to know in future. Okay, it's not about answering the question here. So as you can see, this is propene. You know that alkenes undergo addition reaction. If you want to convert alkene to alcohol, always remember that. Always remember that. Alkene to alcohol. Always remember that. Alkene to alcohol. Get that into your head. Alkene to alcohol. Always remember that. Alkene to alcohol. Not substitution. Addition of what? Steam. Steam. H3PO4. H3PO4 300 degrees Celsius. Then you can get what? I hope I'm recording, man. Oh, sorry about that. I should. Okay. Then you can get what? Do you get? Look. Okay. Let me go back to again. Your alkene. Your water. H3PO4. H3PO4. Phosphoric acid. Then you are going to get what? Propan-1-ol. I need to get this fixed, man. Okay. Propan-1-ol. So you get propan. OH goes here. And H goes here. You get propan-1-ol. What? You can get propan-2-ol. Yes, you can get propan-2-ol as well. So there can be two products here, because the hydroxyl group can go to the second carbon. So when this happens, always remember carbon-carbon double bond gets broken. Then OH can goes to the second carbon. H can goes to here. So in this case, you can get propan-1-ol and propan-2-ol. One step. But that's not what the question is asking you. Question wants you to do this whole reaction in two steps. So how do you do that in two steps? So what do you need to do? If you want to do that in a two step, why are we doing that in two steps? I don't know. That's what the question is asking you to. So let's do what the question is asking. Yeah. So in order to do that, okay, alkene. Always remember that. Alkene. Undergo alkene. Addition. Not substitution. All right. Okay. Then we are adding at HCl or HBr, HI. Doesn't really matter. Hydrogen halide. Always remember that. If you have alkene, man, you have to do addition reaction. Some sort of addition. Right? In this case, we are adding HCl. So then breaks the carbon-carbon double bond. Sorry. That's not how you do it. Break the carbon-carbon double bond. Okay. Then add Cl here. Add H here. So that's 1-chloropropane. Now, okay, that is not what you want to make. We want to make the other product. We want the chlorine into the second one. Why? Because we are planning to make propan-2-ol. So what is our intention? We want to get the chlorine substituted again. Is that clear? All right, is that clear? We want to get the chlorine substituted again. So chlorine should not be there. Then what happens? Chlorine should be here. It's the other product. We need to make Cl like so. Now, if you have that, you know that it's again here, easy. Again, remember, alkanes and chloroalkanes undergo only substitution. Write it down. Alkanes and chloroalkanes undergo only substitution. Chlorine going to be kicked out. Huh? All right. Chlorine is going to be kicked out. So we are going to kick the chlorine out. Oh my God, this gave me annoying. Chlorine is going to be kicked out by addition of sodium hydroxide. That's sodium hydroxide. In this case, just sodium hydroxide, man. Then you get this reaction. What is this reaction? The chlorine is going to be kicked out by the OH. So OH goes here. Don't put H here. O get attached to the carbon, and then you get propane. And you get the CH. H goes to the other side. No, 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 no. It's not going to go. The chlorine is going to get substituted by the OH. Chlorine is going to kicked out. Then the byproduct is NaCl. All right. This is what you need to do. So what is the molecular formula of the compound B? This is compound B, which has to be C3H7Cl, 2 chloro propane, isn't it? 2-chloropropane. Okay, what was the added to the propane to create compound B? And we know that HCl. What is the name of the process which is convert propane to a compound B? We know that it is propane to a compound B. Propane to it is addition reaction. That's addition. Then the next one, compound B, which is this is compound B to compound C. That's simple, man. Substitution. That's substitution. Draw the structural formula. Oh, that is easy. I don't think you will get questions like that, man. Yeah, but what to do? Huh? If they give you a question like that, we have to do the question like that. We cannot do much about that, can we? No. Okay, propan 2-ol. Alright. If propan 2-ol were reacted with acidified acidified dichromate, potassium dichromate acidified. When you hear those acidified potassium dichromate or acidified potassium permanganate, when you hear those oxidation of alcohol. Yeah, you remember that? Oxidation of alcohol. When you hear that, always oxidation of alcohols. Primary, secondary, no tertiary. Tertiary is not going to be oxidized. We know that. All right? Okay. Now, propan 2-ol. Going back to this, propan 2-ol, what type of alcohol is that? Propan 2-ol is primary or secondary? Primary, secondary, tertiary. Primary, secondary, tertiary. Okay, this cannot be a tertiary. It says that it's going to get oxidized, so it should be either primary or secondary. Now, then how do we know which one is which? Look at this. Look at this carbon. The carbon hydroxyl group is attached to. Is called what carbon? What carbon? It is hydroxyl carbon. Hydroxyl carbon. Now, when it comes to hydroxyl carbon, it is attached with two alkyl group. Or hydroxyl carbon has got only one hydrogen. Secondary alcohol. A secondary alcohol. Is that clear? Okay. Now what will happen to a secondary alcohol? Secondary alcohol, when it get oxidized. Okay, let's do it. Secondary alcohol getting oxidized. Okay, this is the secondary alcohol. Okay, let's do the secondary alcohol again. You're doing the secondary alcohol. Okay, because why? It is got a carbon. It's hydroxyl carbon attached with two R groups. That's why secondary alcohol is going to get oxidized. Now it is important when during. I was meant to say during oxidation. All right, the atoms attached to the hydroxyl carbon are the ones going to get changed. Let me write those in a different color. These are the only atoms that are going to get changed. Okay. Always remember, only change the atom which are attached to the hydroxyl group. Only the atoms attached to the hydroxyl group. Is that clear to you? All right. So we are going to change them. Let me get the color. Okay, here acidified potassium dichromate. Yeah. Then what will happen? Look. We don't change those atoms. I told you that only atoms. The red ones can. What is only? You can only rearrange the red atoms. What is it going to become? You know that secondary alcohol get oxidized into a ketone. Other atoms don't change. Again, I need to. Okay, other atoms don't change. So you get this. Is that clear? You get a ketone. The question is asking you. This is what? What's the name of that? This is propan 1. Propanone. Okay, this is a ketone. Homologous series is ketone. Simple. Okay, what are you asking? Huh? What will happen to the potassium dichromate? Oh, you should know that. Potassium dichromate, remember, it's going to get reduced into Cr3 plus. Do you remember the color of the dichromate ion? It's orange, red. I think it's in data booklet. I cannot. Yeah, it's orange color. It is going to become Cr3 plus is green color. Now this is one of the tests you could do to identify alcohol, to identify a primary or secondary alcohol. Does it really matter whether you had heat or not? Doesn't really matter whether you have heat or not. It is still going to become. You can add heat to make sure this is going to go all the way. A ketone going to get oxidized into ketone. Yeah, it's not going to become a carboxylic acid. No way. It's not going to become a carboxylic acid. No. No way. Okay, I'm looking at the data booklet to see the color of these ions, so I cannot remember. Man, I should have known that. The which page you have the color of the color of those ions can be found. Which page is that? Color of selected conjugate, page 5. If you go to page 5, man, you will have those colors. It says dichromate. No, dichromate is not given to you. No, it's given to you orange. Yes, I was right. And green. I was right. All right. Okay, the question 1 is done. Simple question, but then again, there are a lot of learning. Basic learning is there. All right. So I'll come back to question 2 in a moment. In the meantime, see you soon. Bye. I was meant to say in the meantime, bye.